AIoT technology. So what's the sense? Thank you for the time, the introduction. It to bring back warm memories of my time at University of Liên, so where I pursued my PhD. So as you may know, so I hold both my bachelor and the master's degree in electronic engineer from Wuhan University and the PhD degree from the University of Liên. Okay, so I have 35 years of experience in the U.S., France, and China. So I have worked across both industry and academy. Okay, so today that's why I can bring some different insight of some of our research, and also I can bring some the real product, how we implement it, how we bring all the product into the mass production, shipped worldwide. Okay, so yeah, my today's topic is AIoT. So integrating AI and IoT at the edge. Okay, so here is just some basic concept. So IoT is trying to connect the sensor devices to the internet for the information exchange, communication, and control. AI, other end, is involved in enable computer system to ensure the human intelligence, according to application needs. So AIoT actually is combined both. So to create a more efficient IoT operation, improve human computer interface, and enhance the data management analysis. Okay. Here is the challenge of AI. First one is the vast amount of the data collection. According to IDT, by 2020, there are 41.6 billion IoT devices connected to the internet. And the 200 million terabytes for data just floating from the between the sensor devices and silicon. So that means if we actually need 2 million, 1 terabyte desktop in order to handle. If we use this, we need 200 million desktop for each kind of data. Of course, if you take a look at the real implementation, you will see actually this is the information we usually use, is sensor, with edge devices, cloud, and application. So we transfer the data from the sensor to cloud, and then we get back to the execution module. It takes time. It's not easy unless we, for example, in the future we have right now we have 5G, but still not efficient. Data still have the latency. And of course, everybody knows right now Microsoft, Google, and even OpenAI, they try to build a nuclear powerful plan. So because in order to support all these kind of AI and IoT devices. Of course, the data privacy and security is a major concern. All kind of data floating on the internet is a bigger threat. If there is a lot of hype to try to get private data. So, and also the cost is also another concern. So here is the typical AIoT layer model. So everybody knows the OSI model is the same layer model from the physical data link, network layer to transport the session, presentation, and application. Okay. This is the same layers typical OSI model for the order communication. So for the IoT, actually, we also have the typically we are using the same layers. So like a sensor, IoT gateway, IoT edge, and also cloud data storage and cloud-based data stream processing. And to the user interface, IoT user and industry applications. So we simplify, we prefer the 4D. So starting from the sensor execution, edge, sensor execution module for the first layer, there's AIoT edge. Then it's the cloud, and then it's the applications. So this is the typical 4 layer model we are using. So we will discuss each layers. So this is the sensor execution model. This is the usual implementation. So starting from all the 80s, so we are using a microcontroller. So there is a connectivity between the smart sensor. That means usually we say the sensor can connect to this MCU, the microcontroller through the I2C, UART, USB, etc. And then we also have the analog sensor. So of course there is a pre-processing, and also there is a AD conversion. And then of course there is a digital sensor controlled by a GPIO. So we also have a smart execution module through the I2C, EUR, etc. Execution module controlled by the DA and also digital execution module. And the other side actually is a communication module connected to the we call the edge devices. So typically we are using the UART, and sometimes we add a layer that are more fast and convert the sensor execution data to the wireless or wired, like the BT, Wi-Fi, RX8, 485, etc. Okay, so right now, mostly, but as I mentioned before, there's huge data between the sensor and the cloud. But we cannot leave all the data floating from the sensor to the cloud. So that's why right now people try to focus on the edge device. Just like for example, if the edge device for the human being, that's not smartphone. So that's why people right now try to push the AI to the edge. Instead of we connect to through internet to the charge GP, etc. Eventually it's not possible. So that's why edge devices need to have a strong enough process for them to do the neural network, the deep learning, since summer, and also to the signal processing, etc. So usually we are using right now is Qualcomm chipset. This is typical chipset for the international. So because the Qualcomm chipset we are carrying the base, that means that they are naturally support 5G and Wi-Fi, BT, etc. Instead of you add some separate module for the 5G support. So we also have something like the logic produced by China and chip solutions, competitive solutions. So all these kind of AIoT devices today have the storage. There's an IoT gateway. This is also IoT gateway is very important for bridge, for example, the harvesting sensor module and all these kind of sensors. And also it's routing point to connect the internet. So For the IoT, AIoT age, we also need a user interface like LCD, touch panel, audio, video, etc. We also have added some extension. So if you take a look at the right side, you see we have this actually is Office 3399, the core module. For different projects, we will produce different interface for. So then we will make our life easier because for any project we need to do the usually we need to do the case design, the ID mechanic design. We need to do the OS audit, we need to do all the different kind of testing. So use the marginalized and design will make the product reliable and easy. So then they come to the edge device OS. So typically we are using the Linux and Android. Right now, most of our products we are using the Android. The reason why because we can just reuse all the apps for the Android from the Android. So if you take a look at the OS 14, the major work is related to device driver and also IoT API, AI API, and other hardware API, cloud API. Why we want to focus on the APIs? Because, for example, right now I'm in Japan, Tokyo. We have some demonstration for new products. So usually we will not design a user interface for Japanese customer. Because we see that this is the cultural related. Because in Japan, in UI we add a lot of animation. And in Vietnam, we have different design style, and in France, and it's another design. So we will let local engineer to implement some user interface. Then the user they can use their apps to call our APIs, like even the algorithm for deep learning, or even, for example, all the communication between the edge to the sensor module and the edge to the cloud. So everything we will through the API to interact with the apps. Okay. So, and if you take a look at the edge devices, like I mentioned before, right? So to connect cloud, AI, IoT things, usually the cloud is used, we need the computation power to implement the algorithm learning, and we need to connect the API, etc. So the connection between people and the cloud is like smartphone. But for the industrial, the connection between all the industrial applications is edge devices. For the edge devices, we make it has a different size, interfaces, and for the edge devices, usually for the lifespan, usually the smartphone usually for people is 3 years, maybe 5 years maximum. But for an industrial device, maybe 5 is the minimum. We need 10 years. So that's why the devices, lifespan, reliability, and also customization, signal processing, and self-learning, etc. So the edge device, I see this as a big implementation for the AI era. So people have to spend a lot of time on the edge device design. Okay, so here is some edge devices we our company developed, like infrastructure, like the smart meter for the bike station, mobile developed for Korean customers, bus terminals in China, and the kiosks in Japan, and we also support and second the different kind of edge devices. Okay, now let's go back to the one real project where we try to combine the deep learning with our design, hardware, software design for the food recognition. So, if you take a look at for this prototype, we are using a tablet to connect to the camera. So, the prototype we are using the logical 6-core CPUs. They have this 1.6 gigahertz computational speed data, with the 2 giga RAM and 16 giga flash. So if you take a look at the edge devices like this, so we need to first make sure, okay, the model's computation load, so it should be less than 10,000 blocks. So if your computation bigger than that, the edge device cannot do it. Of course, recently there is some like Apple and like Qualcomm, they try to build a powerful edge devices and powerful SoC in order to add more computation power at the edge. But still, the edge still has a lot of limitation. So when you do a project, you need to calculate. Okay. Second one is the number of the model parameters should be less than 100 million. So this is the model when we do the training, build the model, we need to consider. Okay. And also, if you take a look at actually there is the stage 1, if you take a look at the right pictures, there's a model generation. So we started from the food image, we do the pre-processing, then based on that we build the base model. Based on the base model, we take a look at comparing all the algorithm that existed. Then we went to the model improvement. And after that, we do the model validation, and eventually we generate a real model, neural network model for this project. And at the age, so we are doing the model inference. Okay. So the learning should be either in the cloud, mostly it's in the cloud or the server, because there is a lot of computation. Okay. So then we will do the different, if you take a look at there is some when we detected the fruit, we will do the inference, and then we will display the result. Usually, if you we will just when we detect the fruit, we will have the top 1, top 2, top 3. Because usually, for example, when we detect the result is they show to the top 2, but actually the people involved say, okay, actually this is a pear, not the apple, for example. Then all the different subset of the apple. Then if people click the top 1, then but the neural net shows top 2, the category 2, or eventually the fruit is the category 1. Then when people click category 1, so that means the neural network cannot find the real top, because based on the calculation, they said, okay, there's something wrong. Then we will save this data for the model for the iteration. So, or we call it save many. All this data from different on-site terminals sent to the cloud. And in the cloud, we will categorize the misidentification data. And based on that, we will do the iteration and all the fine tuning. Okay. In order to generate a new weight for the neural network. And based on that, we will test in the cloud, and then we will update to the device, the edge devices. Okay, this is the typical 4 steps we are doing for example, trying to combine those edge devices. Okay, I will accelerate that. Okay, here is the algorithm we are using, the basic algorithm. It's basically we are using the dense stack 169. And based on that, we are adding Rama. And in order to have a better focus on the detailed texture, because for the different applications, we need to know what's the natural behavior of that fruit. We need to know some detailed features. Okay, we make the Rama. And also, we add the VIP block in order to capture some in order to we have better understanding of the fruit, and eventually, so the algorithm is like we add Rama.
Recording stopped. Recording in progress.
Okay, so we are close. So if you look at the heat map, you will see with our solutions we can detect more details instead of the dense network. And also here is the comparison with currently existing in the algorithm and with our algorithm. So we have a pretty good result. We reached 95, top one. So from the some fruit on the supermarket. Okay. So the last page we will show. So we also have some sick phone solutions which used for the senior care. And we also right now we are working with Professor Zhang's lab. We are add some of our solutions in the tech stack. Okay, here is my presentation. Thank you for everyone. Hello.
Okay, thank you very much, Wei, for this excellent presentation. And now we switch to questions, have some discussions. Any questions? So I think this presentation is excellent because it covers not only academic algorithm, general structure, but also industrial business solutions. It is more complex. Yeah. That's it.
Thank you for your presentation. I have a question about your solution, your device. Can you tell us what is the energy consumption of your device comparing with the existing solution?
So you mean the hardware implementation? You mean the device?
Yes, the hardware part, yes.
Okay, so if you take a look at the picture here, that's a good, very good question. So actually we typically are using Qualcomm chipset. Qualcomm chipset, like I mentioned, this is a very interesting. We are using the Qualcomm chipset chipset right now we are using QCM2290. This chipset is not, the CPU is not so powerful. It's 4 cores, quad cores. But the GPU is very powerful. So this chipset, we can add a lot of algorithm for the AI, for the deep learning, and for the natural one. Another one is the logic. RK3399. Actually, they already built the NPU and GPU in the SoC. So we can put simplify all our algorithms. So I think the CPU selection will be very critical when you build your system. Yeah. I don't know if you answer your question.
That's okay, thank you.
Thank you. Other questions? For all participants, okay, it's an excellent opportunity to exchange. On my side, I have a question, especially about medical application, because Sinoware developed a lot of medical devices. Probably you can give more details about these applications in medicine or healthcare, and how is about its advantage related to the other products on the market.
Okay, that's a really good question. Okay, so this question reminded me the cooperation between you and we produce the fetal movement detection. We produce new sensors to detect the fetal movement. And based on that, actually, we also developed a lot of, because if you take a look at the current medical industry, so with the AI and IoT jumping, so actually, people prefer all the different kind of value sensors, like the how we for the senior kid. Okay, senior always has a different kind of issues, like heart issues, blood issues, whatever. So we need to embed all the sensors in the textile in order to detect all the different kind of heartbeat, fetal movement, etc. So I think our focus is on how to embed all different sensors and become the wearable. And to make it, we can detect all the information online. And based on that, so all this information will connect to the, we can have a local algorithm to detect all the, sensor, the behaviors. We also, if we cannot do that, so right now we do a chatbot and talk to the ChatGPT, for example. Then we can detect all the different sensor information. Then in order to tell the if we need to call the kids, if we need to call the emergency, etc. So I think that this is a wearable sensor is key for medical device.
Okay, thank you very much. For your new developed medical sensors or medical devices, one problem is that how can the medical professional experts accept these new devices easily, or what is about the procedure for authorization of these new devices in medical institutions, in hospitals, and so on? Is it complicated or not?
Yeah, that's a very, very good question. Medical device usually is very, very difficult. It takes a very long time. Normally there's a category 1, 2, and 3. So different countries have to spend in order to get the certification. So usually, we need to develop the prototype. Then we need to work with some hospital in order to get the permission to do all the lab testing. And after that, we need to do the certification with the FDA, etc. So that's the most challenging part for the medical devices. So I'm so happy to we worked with the onset, and we also have the project with through the different we can get an advantage from them. We onset very advanced lab to implement all these algorithm and sensor. And in China, we can easily work with hospital. They can do the field trial and to verify the sensor. And after that, we can, send it to the certification like FDA. So this procedural cooperation will simplify the whole process.
Okay. Thank you very much. I already put much time. No other questions? Okay. Thank you very much, Wei, for your kind presentation. Thank you very much.
Thank you. Thank you for your.
So,